We've touched on this idea of integration by substitution earlier. Let's look at it in a little bit more detail, and we'll actually look at it again in extension 2 as well. So, integration using substitution. The basic idea is we want to turn our integral into a standard integral, something we know how to integrate. So the standard integrals, these are the ones that do appear on the reference sheet. So if you're ever unsure, you can always refer. So it has the good old derivative times function to the power of n. So add 1 to the power over the power. The one that appears on the reference sheet is the derivative times the sine of function x. That'll go to minus cos of function x. And derivative times cos goes to sine of the function. And derivative times sec squared will go to tan of the function. And the exponential one, derivative times e to the function x is e to the function x. And derivative over function, we know that's the log of the absolute value of function x. It also has the one where the base is not e, so reminds us, oh yeah, we have to divide by the natural log of a if we get that situation. Now, the most recent ones that we've seen, the derivative over the square root of a squared minus function x squared is inverse sine, and the inverse tan one as well. Notice it doesn't on the reference sheet say or equals negative inverse cos. That's just something we need to know, because it may be more useful to use inverse cos depending on the actual question itself. Okay, now in extension 1, they give you the substitution to use. I think that's the main difference between extension 1 and extension 2. In extension 2, they might still give it to you, but then they might not. You might have to come up with it yourself. So, all right, let u equal 4x squared plus 8x minus 7. Now, the advantage of that, I suppose, is we know the substitution used. The disadvantage is we have to use it, okay? Because you might see something like this and go, oh, hang on, it's just derivative on function. But if they tell us to do it by substitution, we got to do it by substitution. So u is 4x squared plus 8x minus 7. So there's u, it's on the bottom of the fraction in case you didn't notice that. Du will end up being 8x plus 8 dx. Well, we haven't quite got all of du, we've almost got it. We've got x plus 1 dx. That's got something to do with du. It's 1/8 of it. But we now can turn it into a standard integral. It's the u on u, which we know is the log of the absolute value of u. And so now we substitute back in, and we get our answer. Dx on x log x cubed, and they've told us to use u equals log x. So du will be dx on x, and we've got both of those things there. There's dx on x, and we also have log x, so we can change that one to du on u cubed. I'll change that to negative indices there. Add 1 to the power over the power. We get minus a half u to the negative 2. Sub the u back in. There's our answer. Now, here's one from a couple of years ago. And it was a definite integral, you'll notice. It's going from minus 3 to 0. And we were told to use the substitution u equals 1 minus x. So if u is 1 minus x, then du is minus dx. But we now have to deal with the limits as well. But we've got a formula that allows us to convert. There it is, u equals 1 minus x. So when x is negative 3, u is 4. And when x is 0, u is 1. Now, let's see if we can do our substitution. We want negative dx. Well, I've got dx, so that's fine. Square root of 1 minus x, well, that's going to be square root of u. But then I've got x on top. That's all right. If I play around with the u equals 1 minus x, I'll get that, what's it going to be? X will end up equaling 1 minus u, isn't it? Which I can break up. I'll tell you what I might do as well. Let's swap the limits around so I don't have the negative out the front. So I'll swap them around, make them 1 to 4. But we'll be doing 1 on root u minus root u to u. Now, 1 on root u, that integrates to be 2 root u. That's another one that's handy to remember. You see it a lot, the du on root u, and so it ends up being 2 root u, because the reason being, u to the power of minus a half, add 1 to the power, it becomes positive a half, but over the power, over a half is the same as times 2. So I'm going to get the root u is u to a half, so that's going to be, add 1 to the power, 3 on 2. So it'll be 2/3 u root u. So u to the power 3 on 2. Sub in the 4 minus sub in the 1, negative on 3. Okay, let's do this one. This one actually comes from last year's HSC. So use the substitution u equals cos squared x to evaluate. Again, it's a definite integral. So they've told me u equals cos squared x. Du is therefore, bring down the power, 2. Lower the power, cos to the power of 1. Dip the inside, differentiate cos, we get minus sine. The other thing I noticed though is in the actual question I've got sine 2x. But of course 2 cos x sine x is sine 2x. So du is minus sine 2x dx. Now the limits, when x equals 0, u is 1. When x is pi on 4, u is a half. We end up with minus du over 4 plus u, going from 1 to a half. It's a log, isn't it? We've got derivative on function. So I get the log of 4 plus u. Again, I've swapped the limits around. It's going from 1 to a half. I didn't worry about the absolute value signs because I know when I substitute in, that's going to be positive anyway. So I get log of 5 minus log of 9 on 2. We get log of 10 on 9 for that one. So 0 to 3 of x on the square root of x plus 1. But this time, they want us to use the substitution x equals u squared minus 1. So instead of making the substitution u equals, they've made x the subject of the substitution. Now when you do that, you just need to be careful. Because we've made x the subject, sometimes you need to consider the domain of the original function. But x will equal u squared minus 1. Basically that means u is the square root of x plus 1. So dx is 2u du. And my limits, we change them from 1 to 2. So we end up with 1 to 2, u squared minus 1's on the top. On the bottom we just get u, but we're going to multiply that by 2u du. The u's cancel, so I have 2 lots of the integral of u squared minus 1. So add 1 to the power over the powers. So we get u cubed on 3 minus u. Sub in the 2, sub in the 1, and we have the answer. So 12D, 12E, playing around with substitution. So